One of the most important concepts in data science is linear regression. So let's walk through some of the math that you will need for linear regression. So a line is just going to be described by intercept A and the slope B. So we get the formula y equals A plus bx. So we're going to use calculus and linear algebra to solve for best A and the best B. It's going to minimize the squared distance between our predictions that are on the line and the actual values. So we have y, let's say we have 5 data points. Y is just this 5 by 1 vector. Beta is a 2 by 1 vector. It doesn't have to be, it's for each x. And then let's say x is a 5 by 2 matrix. So we're going to minimize the sum of squared deviations between y and the value on the line. Predict the value for each value of x. So if we just simply expand that squared value, y minus b, y minus sb, we can expand this. It turns out these variables are exactly the same. So we are going to use simple calculus here. We're going to take a first order condition, we're going to do a derivative, and we're going to set that equal to 0. And that's how we're going to get the best beta that minimizes this equation. So if we do this, we get the y's cancel out, there's no beta. We end up getting negative 2x prime y plus 2x prime x beta equals 0. Bring this over to the other side, cancel out 2. We get x prime x beta equals x prime y. We can inverse this to get rid of it on the left-hand side. And we get the famous equation beta equals x prime x inverse x prime y. So if we look at this a little more closely, and we see how it relates to real data. So imagine we have n observations, so they each have an outcome, so just one outcome, y from 1 to n, and then x, there's going to be data for each person, I equals 1 to n, and they may have k characteristics, so this could be anything related to a customer that we might want to include in this regression, and then beta, there's going to be one of these terms for each characteristic at index 1 through 1. So this is a k by 1 vector. And if we do some normal matrix math, we see x prime x inverse x prime y. Take a look at x prime y. We transpose this, so now we have k rows and n columns, so it's k by n. And y is, n by 1. Multiply this together, we get a k by 1 vector. For x prime x, we again have 1 by k rows and columns, but this is n by k, multiply k by n times n by k, we get a k by k matrix. When we inverse that, it's going to remain k by k times k by 1, gives us a k by 1 vector, which is exactly the size of the beta.